Today we're going to leave Earth's atmosphere and enter orbit to discuss something that hasn't been this hot since the Cold War itself: the conquest of space. So let's answer a few questions. Which powers are currently disputing the space race? What are their objectives? And, most importantly, what can we expect in the near future? So buckle up, because we're taking off. As many of you know, on October 4th, 1957, the Soviet Union launched the first artificial satellite in history, the Sputnik 1, marking a crucial milestone in space exploration and igniting the space race between the Soviet Union and the United States. This event, which coincided with the International Geophysical Year, marked the beginning of an intense competition for supremacy in space, with both scientific and military aims. Since then, the number of satellites launched into space has grown exponentially. Between 7,000 and 9,000 satellites are currently in various Earth orbits, 94% of which are small satellites, mostly used for communication. However, it's important to mention that the 1967 UN Outer Space Treaty states that space cannot be appropriated by any nation or entity. Despite this and other regulations, there is a growing presence of satellites with military or secret purposes in space. And who leads this campaign? The undisputed winner of the Cold War, the United States. Although it wasn't the pioneer in the space race, it has surpassed other nations in space exploration and maintaining technological supremacy. Since the creation of the United States Space Force in 2019, military efforts and projects in space have significantly increased. A key example is the X-37B, an orbital test vehicle manufactured by Boeing, which has the entire world watching with suspicion as it smells like a military or espionage project, something prohibited by international law. The X-37B was originally developed by NASA in the 1990s and transferred to the Department of Defense in 2004. This vehicle, smaller and autonomous compared to space shuttles, is designed to maneuver between orbits, conduct technological tests, and return to Earth without human intervention. Since 2010, the X-37B has completed 7 long missions, with the 7th still ongoing. It has tested materials, protection systems, and autonomous navigation, performing orbital flights and automatic landings. Despite the Pentagon's denials of its military purposes, it is believed that the X-37B is the first U.S. spacecraft with military potential since the canceled X-20 Dinosaur project of 1963. On the other hand, in this new chapter where the Soviet Union no longer exists, the United States' main competitor in space is another. As you already know, since the fall of the Berlin Wall, China has significantly advanced in its competition with the U.S. for global hegemony. This rivalry is manifesting in many fields, and one of them is space. To give you an idea, China has moved from copying Soviet models to developing its own advanced space programs, with launchers, manned spacecraft, orbital stations, and state-of-the-art satellites. Many will remember the successful Chang'e mission, in which China managed to land for the first time on the far side of the moon in 2019. In 2020, China became the 3rd country to bring back samples from the lunar surface, and in 2021, it sent its first rover to Mars. In 2024, China's defense budget reached 1.67 trillion yuan, about $231 billion, marking an increase of 7.2%. Additionally, the Chinese have an ambitious space program with more than 100 launches planned for 2024 and the deployment of 290 spacecraft, setting a record for the aerospace industry. The Asian giant is developing 2 super constellations, Wang and G60, with a total of 25,000 satellites to support both civilian and military purposes. In case you're wondering, this super constellation is essentially a large number of satellites operating in low orbits to work together, ensuring that any point on Earth is always within reach of one of them. A well-known constellation is SpaceX's Starlink, which has more than 40,000 satellites in orbit. In the military realm, China has demonstrated capabilities to disrupt or destroy satellites in orbit. Its Shenlong spacecraft, called the Dragon God, is similar to the American X-37B, a reusable and autonomous spacecraft with potential unknown military applications. Well, the Shenlong has carried out 3 missions, deploying various objects in orbit, likely satellites or payloads, for technological tests. And what about the former great champion of the space race, the Soviet Union? The Soviet Union, a pioneer in space exploration, left a legacy of launchers and satellites like the Soyuz and Progress, which Russia is slowly replacing with the Angara and Amur SPG models. The Baikonur Cosmodrome, a historic launch site for missions like those of Yuri Gagarin and Valentina Tereshkova, faces an uncertain future due to international tensions and the end of the International Space Station, ISS. Yes, friends, the ISS's lifespan has been extended several times, but it is widely accepted that extending it beyond 2030 would be very risky. Meanwhile, relations between the United States and Russia are at their lowest point, worsened by the war in Ukraine and Moscow's strengthened ties with Beijing and Pyongyang. In February 2024, the United States accused Russia of launching an anti-satellite weapon with nuclear capabilities, which Moscow strongly denied. The reality is that this technology is available to the 3 major powers. Clearly, with the ongoing war, Russia has significantly increased its defense budget, and satellite production will also rise. One of the most ambitious projects is the Sphere constellation, which aims to deploy over 1,000 small satellites by 2035. As you can see, everyone wants to fill space with debris. Meanwhile, India, through its space agency ISRO, has made remarkable advances in space exploration in recent years, establishing itself as an emerging space power. In 2019, the Chandrayaan-2 mission aimed to land at the moon's south pole, although its lander failed. In 2017, the PSLV C-37 set a world record by launching 104 satellites in a single mission. Additionally, India is developing the Gaganyaan, its first manned spaceflight program, with the goal of sending astronauts into space in the coming years. With these achievements, India continues to expand its technological capabilities and influence in global space exploration. The European Space Agency and Japan also possess significant capabilities for space exploration, although nothing comparable to the United States, Russia, or China today. However, it seems this space exploration is far from being a Cold War as in the past. The interests here are much more particular, and rather than a war, it resembles a gold rush, similar to what is happening with the Arctic. The most significant example of this is our beloved moon, our favorite satellite, declared the heritage of all humanity. It has gained renewed interest due to the discovery of valuable resources that could be economically exploited: helium-3, water, titanium, rare earth elements. This interest has driven a new space race with significant economic implications. And you may wonder, is this allowed? Well, the exploitation of lunar resources for economic purposes is permitted by the Artemis Accords, signed in 2020, which aim to regulate international cooperation in space matters. And do you know who pushed for these agreements? The United States. And do you know who hasn't signed them? Neither China nor Russia, who complain that these agreements are tailor-made for Uncle Sam's benefit. Through its Commercial Space Launch Competitiveness Act of 2015, the United States allows American companies to exploit these resources. The next U.S. crewed mission to the moon, Artemis 3, is scheduled for 2026, aiming to establish permanent bases. This mission will mark the beginning of a sustained human presence on the moon, focused on resource exploitation. For its part, China has also joined this race, having carried out successful unmanned missions to the satellite and planning to send astronauts in the future. Both nations see the moon as a source of valuable resources essential for future explorations and for the Earth's economy. The question here is how these resource benefits will be distributed, whether they will be shared by all humanity, as they are supposed to be, or monopolized by the companies exploiting them. Yes, friends, what seemed like science fiction is turning into a new reality: artificial intelligences and lunar bases. But this isn't a movie. Space is increasingly being considered a potential domain of conflict. Given the importance of space for humanity's prosperity and advancement, there is a need to update international regulations signed over half a century ago to ensure security, stability, and cooperation in this domain. Additionally, it is crucial to ensure that space activities are sustainable in the long term and that our planet's orbit does not become littered with debris. And that's all for today. If you liked the video, don't forget to like, subscribe, and I'll see you in the next one.